management. It's a great pleasure that being a convener of this 3 days training program with the collaboration of SRM IST and NIDM, National Institute of Disaster Management. So past 2 days we were seen with the different speakers from different domains on which the technologies of disaster management has been clarified with great experts, either in terms of big data analytics or IoT, and then yesterday with WebGIS classifications. And today here with us, the three panel experts who are well versatile in different domains of technologies with respect to disaster management. So let us gain more knowledge with this in this domain. So let me introduce the first speaker, Dr. Gladius Jennifer, who is an associate professor at the School of Public Health, SRM Institute of Science and Technology. So Madam is with us at SRM IST for past 2 years, and she has a very wide range of experience with more than around 20 years of experience as a statistician. Her undergraduation is on statistics, post-graduation is on statistics, and PhD is also in biostatistics. So Madam has published various quite good number of journals and articles with further proceedings, conference proceedings as well, in a very good reputed journal. And again, coming to her biostatistics background, wherever the medical doctors are to be trained with the biostatistics, Madam will be called as a resource person for that, because she's a hardcore, very well versatile with the biostatistics, I could say. So very recently, Madam is associated with the Tamil Nadu Planning Commission, State Planning Commission, which is a very well-known and renowned body, where she was very much associated with it relevant to the statistics. So I would like to introduce Dr. Gladius Jennifer to the gatherings to present about the biostatistics applications or statistical applications of disaster management. So she is a well versatile woman with numbers and profound statistician. So she will deliver the guest lecture. So ma'am, over to you, ma'am.
Thank you, Vignesh sir. So very good afternoon to everyone. Shall we go for the class? Okay. So today, as Dr. Vignesh sir told, the past 2 days, for the past 2 days, you are learning
it would be
about
helpful.
a lot of technologies which is involving in disaster management.
To interrupt you.
I think yesterday Dr. Ranjit sir told about how they were collecting the data in various reasons, right? Hello? Yes, sir. Am I audible,
Jennifer, ma'am?
Yes, sir. Am I audible?
Yeah, you are audible, ma'am. It would be helpful if you put it in a full screen.
Hello.
It is in full screen only. It is in full screen only.
Yeah, then it is fine. Fine. Go ahead, ma'am. You are very well audible.
Okay,
Thank you.
Okay, sir. Okay, sir. Thank you, sir. So today we are just going to study like how the data can be interpreted if it is collected from the disaster management. So till past 2 days, you know various type of disasters and how they were collecting the data. But today we are just going to get how the data can be transferred as information and how it can be transferred as intelligence, or you can make it as a policy for the future to be prevented. So that is what we are going to learn for this afternoon. So my presentation will go like this. So I just wanted to give you a brief idea about what is statistics, what is disaster and types, and how the statistics are implied in disaster management. And then what are all the common data sources and the presentation of data. And then what are all the models you can use for your disaster management data set. So the objective of my presentation will be to make the academic fraternity to appreciate and understand the role of statistics in disaster management. So you know how the disaster is there and how the data is collected. You have many data, seasonal data or panel data, or you may be having yearly ones data, whatever it may be. But then how we are going to interpret those data and how we are going to prepare for the future epidemic or a pandemic or some kind of disasters. So to utilize the service of the statisticians fruitfully in disaster research is the main objective of my presentation. So let me start with the definition of statistics. So as you all know that, see, statistics, you know the term already, you know the meaning of statistics, right? So it is nothing but the science of obtaining and analyzing and interpreting the data so that you can understand and then you can improve your environment by using that information. So it always answer your question. Say for an example, since we are having a theme of disaster management, say for an example, whether some kind of flood has happened, right? In 2014 and 15, the Chennai had suffered with the flooding, right? So if suppose we have that kind of data, so we can predict how the flooding will be there in the future years. Okay, so we can study the pattern from the 2014 to 20, and then we can predict whether the flood will come in Chennai city in this year or next year, whether it will come or not, or whether we'll have a drought or not. Like that, to predict something, we need the statistics. So what it is actually turning the data into the information, so that from the information you can gain your knowledge. So that is what the statistics means. In simple way, you can say that it is nothing but the study of uncertainty, or you can say it is a study of variations. We may be having a lot of variation in the disaster data sets. So I don't need to define about this disaster because you have already learned these in 2 days. Okay. So any natural or a human-made calamities that cause a severe damage to the livelihood, either it may be human or animal or a plant or whatever it may be, that is known as a disaster. So some disaster can be preventable, some may not be preventable. At the same time, some can be predictable and some can be not predictable. So basically, this disaster is broadly classified into two ways. One is called natural disaster, the other one is called man-made disaster. So what are all the natural disaster like earthquake, flood, landslide, and volcano or cyclone, all those things are natural disaster. We can't prevent all those things, but then we can able to predict by using the data, the past data, the seasonal data, or the yearly data, or it may be a secondary source data, but then we can able to predict something. Okay. But in the man-made disaster, or it may be biological, it may be due to the chemical, or it may be the nuclear disaster, which can be preventable in order to avoid or in order to follow some particular rules which the government says. In that time, we can prevent this disaster. So what are the types of this disaster management? I think you know all these four terminology, right? So the disaster management mainly aim to reduce or you can avoid the potential losses from the hazards. The hazards may be anything. It may be a natural or a man-made, but we wanted to manage it, right? So there are four terminologies mainly used in this disaster management. One is called preparedness, then response, and then recovery, and then mitigation. So this is something like a cyclic procedure. So we need to go like always we need to have a prepared. How? Because using your data. So what has happened in the previous year, by seeing the distribution, by seeing the pattern, by seeing the trend, we can prepare for the future. And also sometimes you need a response. How will be responding? Say for an example, suppose you are predicting that this are all the area where the landslide will be more or the rainfall will be more, something like that. So you will be plan or by a program or by a government rescue team or by some other NGO, you will be trying to respond for the natural calamities which will going to happen in period. And then you need a recovery support, right? See, you maybe get ready with your all supporting team to recover that particular problem. And mitigation is nothing but you are trying to prevent by seeing your old pattern and you wanted to reduce it or avoid the natural problem. Okay, so that is what the four terminology or the types which is involving in your disaster management. So the mitigation, which helps reducing the impact of disaster or eliminating it completely. How? By seeing your data. So, and keep on stressing, right? And keep on stressing the data because that is the only key which will tell you or which will able to predict that this kind of area is not suitable to live, or the weather is not suitable to live human or animal, something like that. So that is why I'm keep on telling that the data, whatever you are collecting, because yesterday they were describing, right, like how to collect your data. If see, basically the data is just the input. Okay, what kind of input you are giving, the output will come like that only. So that is why, see, I think you may be reading a lot of papers and other things, like you may be saying like today the rain will come, but we will be having sunny, right? So sometimes they will say it will be sunny, but we'll get rain. So sometimes this will also differs, but then also what they were doing, they are likely to give like these 3 days or these 5 days. We may get or we may not get. So what they were doing, they are trying to predict that if these kind of weather, or these kind of clouds, or these kind of wind, you may tend to have a rainfall or a sunlight, something like that. So that prediction is done by this disaster management or the steps of mitigation. And then preparedness, as I told you, when the disaster is coming and you are trying to prepare in order to avoid or reduce it. And then the response, if something has happened, we need to have a action plan to recover from that particular scenario and then recover. So all these things are very important. So I don't need to explain much about it because you know. So where this role of statistics comes in this disaster management, this is the main aim of this session, right? So as I told, whenever the disaster has happened or the natural environmental data you have, the data, statistics will help you to study the impact of your disaster, and that will use to estimate the damage or the loss or the disruption to the function and service which is caused by that particular event. It may be a cyclone, it may be a rainfall, it may be a flood, whatever it may be, but the data, that statistics will help you to study the pattern and the trend. So that is what the statistics come into play in the disaster management. So basically, as I told, the two, we know that there are 4 types, right? But the 2 types are very important because the preparedness and the prevention, that is mitigation phase. In these 2 phases, we are using the statistics. How we are using, if I say for an example, you are in the term of preparedness. So what will you do? You will be monitoring the data over a period of time, maybe in the regular interval, maybe month-wise, maybe day-wise, or maybe year-wise. You are trying to monitor the data and see how it is going. Some days, see, we know that seasons, right? Summer, winter, and this thing. How we are doing the increase of sunlight and decrease of rainfall, something like that, right? So we are monitoring and then we are predicting something. So the forecasting is nothing but the predicting. So by using this monitoring and forecasting, you are trying to give an early warning, right? So these are all the hard spots. We may get some kind of disasters or some kind of flood or cyclone or whatever. So we are trying to give an early warning and we are trying to plan some kind of policies and the national programs in order to avoid the disaster. And then the next level, the prevention, that is the mitigation phase, where we are trying to analyze our data. Okay, we have some kind of data. The first preparedness level, we are just seeing the trend and we are finding that, okay, these are all the time we may get. But this prevention, that strategy will help you to identify what is the real risk factor to happen this particular disaster. And we are trying to analyze by using the data we had, and then we are trying to apprise the report, what is we are getting out of the data. So after doing all those kind of analysis, we are trying to create an awareness to the public and also by health education system, the public education system. So these 2 phases are very important where we are using our statistics. So this is very common thing. Hopefully everybody knows these things. So usually the data, whatever you have, is broadly classified into 2 ways. One is called quantitative, the other one is called qualitative. So quantitative means whenever you can able to measure it. But say for an example, rainfall, yes, you can measure. The weather condition, yes, you can measure. So whenever you can able to measure it, then you can call that particular data or the variable, you can call it as a quantitative. If your variable is in a whole number like 1, 2, 3, something whole number, then you call it as a discrete. And if you have a fractions of the decimals, then you call it as a continuous. But these are all measurable. But in a qualitative, we are classifying it as a nominal, ordinal, interval, and ratio. Where if suppose you have a data saying like there is a mild landslide, moderate or severe landslide, or you are categorizing that heavy sunlight or low rainfall, something like that. Whenever you are categorizing something, then you can call it that variable as a categorical variable, or you can call it as a qualitative variable. So whenever you have just a category and it is not having particular order, saying like heavy rainfall, low rainfall, just to category, something like that. Just if you're just categorizing that there is no proper order in it, then you can call it as a nominal variable. But you're categorizing and it is also in particular order, like mild, moderate, severe. So say for an example, when you're trying to fit a GIS map and you are trying to fit with the rainfall data or the prevalence of any other diseases, then you will be having some order, right? 0 to 500, 500 to 1000, 5000 to 10,000, something like that. So that time, that scale is known as an interval scale. Whenever you are able to see your GIS map, you may be seeing the scale in the left corner where there will be some kind of interval, right, with the different shades. So that variable is known as an interval scale, where you have a category and it is also in order, and you know the starting and ending point. You have some numerical value, right? So starting and ending. So that variable is known as an interval scale. And also we have one more variable called ratio variable. And most of the disaster management type of data, we are not using that ratio scale. But up to interval scale, we are using that. So if suppose you have a data, then how you can represent your data? Usually, the representation of your data can be in two forms. One with the tables, the other one is a graphical representation. So the table can be a very simple table. If suppose you wanted to say that these are all the area and this is the rainfall value and the percentage, just frequency and percentage, then you can call it as a simple table. Sometimes you wanted to predict association between two variables, like as the rainfall increases, the landslide may increase, something like that. You wanted to predict some associations or the relationship. Then you can go with the contingency table if your variable is qualitative in nature. Okay, I'll repeat once again. If you wanted to find out the association of two different variables and it is in a qualitative nature, then you can use this contingency table. So these two are the varieties of table. But in the graph way, you have many graphs, right? You may be seeing these kind of graphs in everywhere, whether in the newspaper or in a web portal or anywhere, you're seeing a lot of graphs, right? So there are histogram, frequency polygon, or-give, line diagram, scatter diagram. So many diagrams are there in the representation of data for a quantitative. But then in the disaster management, since we are having a time series data, that is over a period of time, we have a data set, right? So usually we are trying to predict in terms of line diagram. Okay, I'll repeat. Since our data set are usually a panel data, that is time dependent data. So we are always wanted to show either in a line diagram. Suppose you wanted to find out a relationship, you will be representing that with a scatter diagram. Okay, so these two diagrams are very important for our disaster management data if your variable is in quantitative in nature. Suppose, as I told, you have a categorical nature, you can represent in terms of bar diagram or a pie diagram, okay, or a pictogram, which is equivalent to the bar diagram, but with the pictures. So these are all the way of representing our data for the disaster management data sets. Okay, so you know that you have some data you have collected by GIS method or some secondary sources of method, and you know how to represent in terms of the table and product. Suppose you wanted to predict something, right? So basically, there are two options, right? One thing is just to describe your data and then finish off your paper. But the other main important is we wanted to predict something, right? We have some data, and with that data, we wanted to predict something. We wanted to test our objective. That is what the main aim of writing a paper or your dissertation or a thesis, right? So whenever you have some kind of objective, you want to prove something, then what will you do? You will be writing your objective as a hypothesis, right? So usually the hypothesis is nothing but the scientific way of writing your objective. So you are right, you are trying to test your hypothesis. So if you are getting a evidence for that hypothesis, then you can say that yes, my objective is correct, right? So when you wanted to test your hypothesis, you have major 5 steps. What is that? The first step is creating your null hypothesis. So the null hypothesis will tell you that there is no difference between these two data sets or these two groups, or there is no relationship between these two variables. Likewise, we'll fix the null hypothesis. And then what is our alternative hypothesis, which is nothing but our objective, right? That is what we wanted to prove, saying that yes, there is a difference between these two areas, or there is a exact significance relationship with this rainfall and the landslide. So that is your alternative hypothesis, which will support your objective. And the third point is fix your level of significance. That means your p-value. Okay. So the level of significance, in other words, you can say it is a type on error, right? So you are allowing only 5% error to occur, which is beyond your control, which is just because of your chance. It is not because of your objective or the test. Okay. Then finally, choose your statistics wisely. That is nothing but your test of significance, whether you wanted to compare the groups or whether you wanted to find a relationship between, or you wanted to do some trend analysis, or you wanted to do some text analysis, or you wanted to do some sensitive analysis, whatever it may be, that choose your statistics at the field. And finally, whether it is significant or not. That these 5 steps are very important when you are trying to write or test your hypothesis. So, as I told, you have a hypothesis, you have a research question, you have a hypothesis, objective, and other things. Now we are trying to do your analysis. You have a data also, right? So, what are the statistical tools I can use for my data set? In general, this statistics is broadly classified into 2 things. One is called descriptive, the other one is called inferential. Descriptive means you're just trying to describe your data in terms of frequency percentage if it is qualitative. Otherwise, you can represent in terms of mean, median, mode as a central tendency, and range, quartile range variation as a measure of variation. If I say for an example, if you go for your review of literature, I think everyone would have been read some kind of article on the disaster management, if I'm correct. So when you go through those articles, you may be coming to know that if suppose it's rainfall, they either would have been given with the mean rainfall bracket standard deviation. Am I correct or not? Or sometimes they will give mean plus or minus standard deviation because the rainfall is a quantitative. So at that time, they will be describing their data by using mean and standard deviation, which is the gold standard parameter for the quantitative. And if you see some area-wise rainfall, they will be saying in Coimbatore, this is 2% rainfall was there, or some kind of percentage or some kind of number they would have given, right? So that is called as a simple table, or you can say that they were trying to describe the statistics with the simple values. Okay, so that is known as a descriptive statistics. But it is not going to give some kind of influence, or it won't give any p-value. In that time, what will you do? You will be going for an inferential statistics. So there are a lot of inferential statistics are there. Maybe if you go, if you are used to read the article, you maybe come to know that the student t-test. What is that? If suppose I have 2 different data sets, say for an example, I have some rainfall data for the urban side and I have some rainfall data of the rural side. Okay, I wanted to compare. Is there any significant difference in the mean rainfall? I'll repeat. Is there any significant difference in the mean rainfall? In that scenario, what I will do, I will use this t-test. Okay, I will use the t-test. And suppose I have very small number sample, then I will be using a non-parametric statistics. But if I'm not having a small sample, I have a very big data set and have a mean and standard deviation, which is normally followed, then I will be using the parametric statistics. Similarly, suppose I have a particular mean value for the last year, 2020, and I have the average mean rainfall for the 2022. If I wanted to compare these two values, because the same area in the Tamil Nadu only, but then I wanted to compare the last year value and with this year, the same area 2 times I wanted to compare. If so, then I can use this pre and post test, which is called as a quantitative test. If I have a large sample, I'll use a quantitative test. If suppose I have a very small sample size, I'll be using composite scientific test. So if suppose I have more groups to compare, maybe Tamil Nadu, maybe with the Karnataka, maybe with the Andhra, and I wanted to compare all these things simultaneously, then I can go with any kind of evidence. Okay. So these are all the differential statistics. I wanted to prove that there is a significance. But then, as I told, if I wanted to predict finding the association or finding the correlation between two variables, then what will I do? I'll be going with the correlation, Pearson correlation, Spearman correlation, Kendall's correlation, and so many things. If it is a qualitative variable, then I'll be using chi-square test and the Z test. See, this is all just to give an idea only. It is not the intent to study all the tests. Okay. Okay. So these are all the in general. If you have a data set, you will be doing this descriptive and inferential. But as I told, in the disaster management, we are not only interested in this descriptive statistics. By seeing the map, by seeing the percentage, we are not going to get anything, right? But we are just going to show the map. These are all the area had a flood. These are all the area had a big landslide. That is not going to give a purpose for the research. So what will we do? We are not going to stick on only with this univariate analysis, but then we were trying to do some kind of multivariate analysis. Okay, multivariate analysis. So that multivariate analysis only will help us to predict something. So whenever you have an idea of predicting, then you need to remember one particular technique, which is called regression technique. Okay, which is called regression technique. Whether you have a quantitative, there are some kind of regression methods out there. Simple linear regression, multiple linear regression, and so on. If suppose it's a categorical, you have a logistic regression, you have a multi-nominal regression, nominal logistic regression, probit model, so many models are there. But everything is based on the regression model. Okay, so here I've just given 2 examples. The first example is from the Myanmar, 2008. There is a cyclone data. Okay, there is a cyclone data. So what they have done, they first find out the correlation between the wind with the population damage and the rainfall with the population damage. So they find out that there is particular correlation. So once they found out that correlation, what they were trying to predict, whether is this variable is really contributing in order to calculate our damage index. So what they have done, they trying to predict a regression model. So what they have done, the population damage index as a Y variable, it's a dependent variable, and then they put the wind and rainfall, it's an independent variable. So they were trying that as the wind is increases, the population damage is increasing. As the rainfall is increasing, the population damage index will increase. So they will fit the model so that they will predict that if the wind is going to be high, okay, there will be some damage. Give an alarm. So if the rainfall is in, they plan the rescue and things or recovery management things. So likewise, they try to predict it by using the regression. And I have given the second object. What is that? Again, this is a flood. Okay, they have a flood map in Malaysia. Okay. See, yesterday you have seen a lot of GIS techniques, right? So they had a flood map. Even Ranjit sir was showing about the aerodrome and the river flood and other things, right? So same thing. So what they have done, they had a data in a Google map, like GIS technique. So what they have done, they were categorizing severely affected or mildly affected or moderately affected. And then what they have done, by using a logistic regression model, because your outcome variable is a categorical here, right? So they fit the logistic regression. So from this example, you come to know that whenever you wanted to predict something, you are going to use your regression model, which is the basic. Okay. Check. So for the disaster management, our main aim is forecasting. Okay. When the data is there, yes, you can do some descriptive statistics and show the distribution that is there. But then the main aim of the disaster management data is to predict something so that we can prevent the problem. So whenever you are trying to predict something, what technique you will be using here is a time series forecasting. Okay, this is something like a mathematical model. Okay, it is the extension of a mathematical model that we are using in the statistical approach. That is known as a time series forecasting, because your data has some periodical time, right? There is some particular time, monthly wise, day wise, or second wise, something like that. But you have with the time, your data has some time. Okay, but in all other research, we don't have a time in it, right? We are just having the data and we are analyzing. But here in these kind of time series data, you have a panel data and you're getting a data at periodical time. Okay, so in that time, we are going with the forecasting models. So here I just explained with the time series analysis. So the time series analysis is defined like a specific way of analyzing a sequence of data points collected over a particular interval. See, I have given 4 different type of this. See here, something like irregular. See here, this is something on the day wise. So irregular motions are there. And then see here, this is something like a smooth curve. This is something called as a cyclic curve. And then this is an exact prediction. You will be having a straight line. So exactly you can predict with the year versus the other Y value. And then something with the seasonal, sometime higher, sometime low, like our COVID data. Okay. So these are all the way of showing your time series analysis. So usually in the time series time, so your data will have a data points at a particular interval. It may be a day or a month or a year, but then at a period or periodical time, you will be having a frequency. With that frequency, you are trying to predict the trend analysis. Okay, so that is why, as I told, this data is called as a panel data, or you can see it is a time dependent data. Okay, so for that we have a separate models. But of course, everything will follow the regression type only, but then we have a different things. Okay. So under this time series model, we have many options. Okay, the first one is called auto regression and moving average. These two are something like a univariate. Okay, so these two are very important. And then we have auto regressive and then moving average. And then we have auto regressive integrated moving average. This ARIMA model is a very important model. Most of our disaster management, we are using this ARIMA model. Okay, so whenever you have a seasonal data, then that is called as a SARIMA. Okay, seasonal ARIMA. So these two models are widely used in many of your articles. So you need to know about these two, these ARIMA model very well before doing your time series forecasting. So as I told, those ARIMA model as an integrator of two things, right? Auto regressive and then moving average, right? There are two models. Here we have seen two models, right? This is an integrated model. So first we will define what is this moving average. So as I told, this time series model is coming from the mathematical side, right? So basically, in the normal time, the average is a one single value. In the descriptive statistics, we see, right? Mean, median, mode. That is a single value. But then, since there is a time point in this time series data, or your disaster management data, so we are calculating the average at different points. So that is why it is called moving average. One time your average will be high, the other time will be low. Again, it may go high, again it may go low, or it may go stable, stationary, something like that. So that is why we are using this moving average model. So the model is something like this. You don't need to worry about all those things, but just for the sake of understanding, I'm telling you. Okay, we have a data, software. You can feed your data and get the analysis of that. So you don't need to worry about this equation. But then this moving average, pure moving average model will depend upon the error terms. Okay, so usually in the regression model, we have the intercept, slope, and then the error. So this will have a error term as a main component in the equation. So this is the one component among the error. So the next one is an auto regression. See, auto regression means what? Whenever you have a correlation between the independent variable, then it is called auto correlation. Similarly, here everything is depending. See, we know that this is a time series data, right? So if suppose I wanted to live today, then I have to, I am supposed to alive yesterday and previous day and previous day. That means what? I'm depending upon the past values. If I am living T, today is a T, then I should be T minus 1 alive, T minus 2 alive, T minus 3 also alive, right? The same thing. So this is dependent on the lags. Okay, this is dependent on the lag value. So that is known as the auto regression because it is dependent upon the previous value, and we are trying to predict our regression model by using this past. So that is called auto regression model. So when you have an integrate of this auto regression and also with the moving average, then you can call it as an ARIMA. Okay, ARIMA means it is an integration of the auto regression and then moving. That means your average is also differentiated different point of time. But each time you are seeing the lag of the past values. Okay, that is known as the ARIMA. So here you are having these two terminologies, that is called lags and errors. By using that only you are predicting. This is also like a regression model. Okay? You have an intercept and then you will be having a slope for each and every variable, and also you will be taking the consideration of your error terminology. So this is known as the ARIMA model. So it is an integration of AR and NR. Okay, when you are using this ARIMA model for the seasonal data, like month-wise data, if you have for several years, then you will be seeing the seasons, right? This is a season of summer, this is a season of winter, something like that. So when you are trying to see the seasonal variations, then you can call it as a seasonal ARIMA. But the concept is same. Okay, we are using these two concepts of auto regression and the moving average as a univariate process that we are applying and predicting as a multivariate process in ARIMA. Okay, here I've just given some examples. Okay, so I have given different type of example because our students are from the public health point of view. So I just given with the COVID data. So this is a article published recently in 2021, our second COVID wave. Okay, so what they have done is they have taken 230 days data. They've taken the 230 days of data, the COVID data. I think you have seen with the paper and the news daily. This is the number of new cases in every day. Something like that. So they have taken this data set and then they were trying to predict how the second wave will be. Okay, so they predicted that in the April month 2021, we will be having our second wave. So exactly we had a lockdown that time, right? You maybe remember that. So they have predicted that at the 72nd day for the AP, and then 182 days of Maharashtra, and then 193 days there will be high in Karnataka, and 82 days high will be in Tamil Nadu. Likewise, they predicted the forecast by using the existing data, which is existed in 2020. With that help of the data, they predicted the second wave when the peak will be by using this ARIMA model. So it's an exact example for how the disaster, which is the pandemic, right? So in the health perspective, this is also a disaster. In the pandemic is also considered as a disaster. So they use the ARIMA model and forecasted, and then they put the lockdown that particular period of time. And I have given the another example, which is from the fire rescue. Okay, this is not from the health point of view, but then this is another paper for the fire rescue. So there also what they have taken a data set of 2016 to 2020, and then they applied a ARIMA model and how to find out that this rescue operation there is needed and other things. So they use the ARIMA model in order to predict the rescue pattern in the fire. Okay. And then this is another example for the disease prevalence. Okay. So hepatitis B is a highly prevalent disease, wherever it is in India or China or whatever, but the article is from China. So what they have done is they have taken the data set of the hepatitis B in 2017. Okay. So they have taken 1 million people data set, and then they analyzed by using this ARIMA forecasting. And then they found out that which is the proper see, basically the ARIMA model will help us to forecast, right? Early warning gives you, or you can derive some kind of decision making, right? So by using this ARIMA model, they found out that these are all the area is highly prevalent for the hepatitis B, and these are all the area to be prevented for it. So they use this ARIMA model, and then they come up with a program. And then one more example, which is on the hospital point of view. Okay, so whether it's a pandemic or epidemic, we are having a crowding, right? In the hospital, there are a lot of crowding. So many people were waiting outside. We have seen in the news and papers. So how to predict that crowding? Okay, in an emergency department. Of course, this is also very needed, right? So by having the idea of the first wave, we have somewhat built some kind of infrastructure to face the second. And then by seeing the second wave, again, we made a lot of arrangement for the third and fourth, right? So for that kind of we can use this ARIMA method. So this is the example for it. Okay. So at the end of the day, my viewpoint is you have a lot of statistics, but your disaster management data set is mainly having a component of time. Okay. You may be having with a seasonal data or a panel data. So in that time, instead of going with other statistical methods, the simple univariate or multivariate, which we are using for the other data set, will not be give a precise value than this time series method. So the ultimate aim of this session is kindly use a time series model. You may be having a smoothing model and so many things, but my suggestion would be use a ARIMA model or seasonal ARIMA model or the smoothing curve in order to forecast if you are using your disaster management data set. So that is what the ultimate aim. So it gives a highly accurate and reliable answer if your data set is correct. Okay. So there are some more models is also available for the disaster management. If suppose you wanted to see the hotspots, then you can use a spatial approach. Okay, so maybe if you wanted to see how the geographical region is and seeing that geographical and environment condition, also you can predict these are the hotspots may get a disasters over a period of time. So in that time, if you wanted to do that kind of analysis, then you can use a spatial models. So you will be having a spatial cluster analysis, either global clusters, more and I, and so many things are there, autocorrelation techniques are there. So you can use that kind of techniques. Otherwise, you can use a regression model to predict like spatial lag model. So spatial error model is there, and OLS is there, and GWR is there. So many models are there to predict something. Suppose you want to approach your data as a qualitative aspect. Again, we have so many models. There is a Delphi model. You can do an opinion survey in that particular area to know what is their problem, what is their need, and how to rescue what is the need from that stakeholder side. All those things you can do by qualitative, and then you can do with this nominal graph technique also. So on the other side, if you are doing as a secondary sources data, okay, you are not going to meet the people or get the data from the primary source. But then you have a big data, like you may be getting a data from the Twitter, you may be getting a data from the Facebook or some other social media, and you are so many people are tweeting about this disasters or the natural calamities. You have some kind of backside data, right? If suppose you have that kind of data, then you have lot of models for it. So you can do the natural language processing, you can do some sentiment analysis, you can do some text classification like these all the severe one and other things, and then you can do some social media analysis, and then you can also predict their economic status, like by using so many economic models are there. Of course, they are all coming from the regression technique. A lot of economic models are there. You can use that, and then you can use a Navy model. So this is my suggestion that if you have just a seasonal data, go with Arima. If you don't want to predict or forecast something, I just wanted to give something in a distributive way, stick on with the simple descriptive statistics. And if you wanted to correlate your disasters with a spatial approach, then go for this spatial approach models. Suppose I just wanted to know how their physical, mental status by using their social media, then go for the big data approach. Thank you.
Thank you so much, ma'am. Thank you so much for your kind presentation, ma'am. It was very much impressive, and more information we gathered using Arima model is very new to me as well, ma'am. So it's a great learning for me. And yeah, a lot of feedback were floating around when you are doing your presentations, like excellent presentation, and they were seeking your presentation as well. Of course, for all the participants, the presentation will be shared. So few questions, ma'am. You have, being your busy schedule, you have somewhat gave time with us to share your knowledge. So few questions you can answer and you can leave for your current assignments, ma'am. Like first question is, what are the types of time series analysis?
Sir, actually, I have put up that one. The time
Okay, that
series,
is
you
fine.
have many things. Let me go to that. Okay.
So might be,
So
he
this
might
is
be,
what the
yeah.
answer. So many models
Okay.
are there. So the basic univariate model will be moving average, and the next level is auto regression. But when you combine these two only, you'll be going with this auto regressive integrated moving average. So this is the ultimate model you can use for your data. So I was talking about this exponential smoothing, right? So if your data having lot of noises, you want to clean your data and analysis, then you can go with this exponential smoothing. So, but for other data sets like periodical weather data or rainfall data or whatever your environmental data, then you can go with this Arima model. That is what I said.
Yeah, thank you, ma'am. One last question. How statisticians can predict or forecast weather climate change pattern in a vector or raster forms? It's all about mostly with the geospatial modeling, I think so, ma'am.
Yes, sir.
How
In that
statistician...
time, yes, sir, we can use spatial models in order to predict that, sir. Maybe not in the time series model, but we can predict by the spatial modeling, seeing the hotspots by using a local or global estimates, sir.
Yeah. So thank you very much, ma'am. Thank you for your kind
Thank you, sir.
words
Thank
and
you so
kind
much.
lecture, ma'am. Thank you so much, ma'am. Thank you so much.
Thank you, sir.
So,
Thank you for the opportunity, sir. Thank you.
Thank you. Thank you. So next speaker, I would like to introduce Professor E. Puniamal, madam, who is a professor and in Department of Computing and Technologies, SRM Institute of Science and Technology. The area of interest is data mining and big data analytics. So she is associated with SRM for past 30 years, I can say, right from 1996. And she is very much well versed in computing technologies in data mining, and very good publications, more than 70 publications in her bank, I can say. So madam have currently have holded very analogous post like dean, associate dean, and now currently an associate director of campus life of entire SRMIST, and it is not an easy task being associate director of a campus life. I could say one proverb that a successful woman is the one who can build a firm foundation with the bricks which was thrown by others. So madam is a great example for her. He has built her empire with the various failures from others. So it's a great opportunity, madam, to be here with us. So madam, over to you, madam.
Thank you, Vignesha, for the wonderful introduction. Maybe it is true or false. Happy to listen from people like you. Thank you so much. So can I start the sharing?
Yes, sure, ma'am. Sure. Yeah, it's visible, ma'am. Yeah, perfect, okay. Ma'am, perfect.
Okay. Yeah. Very good afternoon to everyone. It is my indeed a great pleasure to be here amidst this amount more than 250 people, and it is made after the lunch time, and we had a very good session from ma'am, Jennifer ma'am, which was about data, and as a statistician, she has given really a wonderful session she has given us. So now I'm just going a little to the other side of how that data, big data, the data is handled computational, using a computational power, how we are going to use the data in disaster recovery management. So my talk will go like this, very few titles only I have chosen. I wanted to be a little crisp. Maybe if I go out of my time, please, Vignesha, please remind me. Okay. So sure, introduction. So introduction and how the big data is used in emergency management. Two ways in which the emergency management is handled using computation, using online methods. One is the connecting people, and the second one is social media mining. And the last one will be about, maybe you will wonder why it is here, Russia-Ukraine war. Maybe I wanted to complete the session with that, about that. Maybe it is, I will be letting you know. So as introduction, I wanted to talk about big data, right? She talked about data, and as a statistician, she has nicely analyzed how what are all the quantitative data, what are all the qualitative data, in quantitative, what are all the categories, in qualitative, what are all the categories, like that. But when you want that data, different type of data, as a statistician, she would have handled, definitely. When you want the machine to know about this kind of data, we have we will be able to handle really a voluminous data, and that data we call it as big data. And even though we say big data, there is no proper size of the data with which we can say that as a big data. It will be anything. Sometimes even smaller data can become big data. The thing is, whenever a data has three important characteristics, 3 V's. When I say 3 V's, then that data we call it as big data. The three V's are volume, velocity, variety. You know what is volume? The amount of data which you are going to handle. Then velocity, the speed with which you are going to collect the data. Maybe yesterday also you would have heard how the data from internet, the connected things, from that we are collecting the data. Even for, let us assume in a Facebook, how much data we are uploading. In a fraction of seconds, so many photos are uploaded. And the speed with which you are uploading, or you are occupying the Facebook, any cloud, that is the speed. And with that speed, when you are getting the data, that also to be handled. Then the third one is variety. Not necessarily all the data are in structured format. Some may be in a database format, like table like. Some may be photograph, video data, audio data, or some may be text data, but which is very much unstructured. Now, so a data which has these three characteristics, volume, velocity, and variety. If they have, we call that as big data. And of course, now people are adding number of V's into that. But these 3 V's are very, very important: volume, velocity, and variety. Now, when even though we have data, practically speaking, data is an experience. So when you have voluminous data, when you are processing voluminous data, most of the decision which we take will be right. So it is now we are in that data-driven world. All the automated decisions are made from the data. So the data, the volume with which you are able to get the right volume of data, or in the sense clean data, will be able to take the right decisions. Then the history, because I need to connect that big data with disaster management, isn't it? So that's why I wanted to tell about something like how normally in history, what happens is when you analyze history, you'll find that numerous policies have not been effective when it comes to rescuing people who are amidst disaster environment. So the problem is maybe the way which you must be knowing in the earlier days when we are taking that population, they will come for statistics collection. That time it will take years to gather. Previous 3 years data they will give. After that only population will come to know. So the speed, the collection, it takes longer time. But now as the innovations are constantly evolving and technology we have improved a lot, it is time that administrations should focus more to include various technologies which help in prediction of disasters and their relief work. So whatever may be the volume, whatever amount of data which we collect, that should be usefully analyzed, and that should help us in making our life safe. So that is the most important part, and that is why I am talking about that. Many recent technologies were not there 2 decades ago, right? So advancement in the way in which we are communicating, it leads to a considerable reduction in the number of casualties as well as injuries, even nowadays. Agencies like NASA and NOAA, that National Oceanic and Atmospheric Administration, they have used big data technologies for prediction of natural resource disasters and coordinate with the personnel in case of emergency. In case of emergency, the emergency situations are handled by those kind of agencies. So the role of big data or the big data technology is a great source that has been continuously proving its mettle in disaster relief, preparation, prevention. And ma'am was telling, no, mitigation, preparedness, recovery, or in all the places, the big data, the analysis of the data gives us a great information. The big data helps in response agencies by identifying and tracking the populations. So it help in the big data system help in purpose of coordinating with rescue workers to identify the resources which could provide support and do logistic planning in emergency cases. You must be knowing how that huge amount of India, the population in India, we were able to get the vaccination because of the data. We know in which place people have vaccinated, and of course, thanks to that mobile apps, mobile applications developed by the government, and even the government agencies gave the data on time. So they were able to plan very well about that the distribution of injection. Initially, there were some issues, but quickly they were able to recover because and distribute the injection to all the people at the right time. And this kind of technology really helps our government, and the data, as repeatedly I'm telling, it has a major role to play. So the 90% of the data in the world was generated within last 2 years. So because we are living in digital world, everyone is generating. Now, if this data is carefully handled, definitely lead to we can handle the disaster in a very effective way. So about the role in the disaster management, I wanted to say a few sentences, I should say, that is crisis mapping, bringing people together and preparing for the emergency situations. So in crisis mapping, one non-profit organization, which is Nairobi's there is one special community, Ushadi. They created an open source platform of software to gather information. So this technology works on mapping the platform, which was first developed in the year 2018, analyzing the areas that become violent right after the Kenyan presidential election. So information at that particular time came through social media and many eyewitnesses. They all deposited the data in that. Then the team members then put up the same information on the Google map. So that was very interactive and helping the residents get cleared of their danger. It was very well handled at that time. Similarly, the same technology was used again in the year 2010 when Haiti was through the earthquake, providing integral part in saving the lives of numerous citizens who were in that region. Okay. Then with respect to second point, bringing people together, Facebook and Google, they are very really genuinely they are leaders in technology, big data technology, and they too have invested in the development of some advanced resources which have their benefits during the time of natural disasters. Anyway, I will be talking about two typical applications of that I will be dealing it in the next few slides. And the last one, preparing for the emergency situation, how that is, big data is, 10,000, more than 10,000 people killed and more than 95 million affected in the year 2017 for Hurricane Harvey. It's the data available in the internet. So based on that, I'm telling Hurricane Harvey and a massive earthquake in Mexico and mudslides in Colombia. So in 2017, it was very disastrous things happened. Also 2018, and of course we know in 2020 again. So about with all these disastrous examples, one good news is that proliferation of data analytics and sophisticated technology save lives in the face of disaster. Definitely, it played a role. System working in big data are continuously making it better for the agencies to predict and forecast. As ma'am was telling, prediction, how it is done, and we also experiencing it. In the earlier days, we used to say the prediction was not that perfect, but almost now we are also improving. The thing is, people also ask why in the other countries they were able to predict very accurate. We are not able to do. The one more thing is the constraints. So Madam was telling about regression analysis and constraints. Now the constraints in cold countries may not be that much affecting the equation which you form. Whereas in India, our climate has that issue. That's what informed by one of the experts from meteorological department that I wanted to convey here. Anyway, coming to emergency management. So as I was telling, effectiveness of emergency and disaster management can be very well handled by big data. The reason is, we are getting real-time data. I should not say that in information. Actually, real-time data you get using the smartphones and social media instantly. Whatever happens, if there is, if some 10 boys are crowding at a place and from 15 girls are in a place, if they wanted to attract people attention, they know how to do it. So that is the power of social media and smartphones. Now, this data, this real-time data, at instant, at that place which is happening, that is known to a person who are in the extreme corner of the world. So this data is definitely, if it is effectively used, you can handle the emergency situation and disaster recovery system very effectively. The other part, connecting victims with emergency responders and family. That is, this is the other one. Once it happened, is something as she was telling, natural disasters, which we don't have any hold on that. In that case, if something happens also, whether we are able to connect to those people and we can extend our help to them. For that, the enhancement also can be done by the data which we are collecting. So as I told you, we are going to see fewer more slides which will tell us how that families can be connected and how the social media mining is going to help you in handling the emergency cases. Now, so the first one, as I told you, Google and Facebook, they were very good. They are giants with really a large amount of data. So they wanted to handle the emergency situation with the data they have. And with that, they wanted to reduce or very sensible decision they need to take and quick decisions which we make based on the data. And so that will reduce the recovery time. Once the disaster happened, we need to recover quickly. And so suppose a set of people, they are dispersed because of some disaster, and they can connect. And one of the online system is Google Person Finder. The other one is Facebook, and which is in Facebook you have a menu called Safety Check Service. Maybe some of you would have used during our COVID time also. So these services actually use that big data as their recovery tool. So about that Google Person Finder, in 2008, as I was telling you, in earthquake in Haiti, the Google released this Person Finder in the Google itself as an add-on feature. And so whenever the person who are getting connected to that information can be easily reached to everyone. And in case I wanted to search for that individual from that place, I don't know where he is. So I can also put or create a record and telling that I'm here waiting for you. Or we can tell who is the person who is in this disaster situation and who is okay, I can manage. That kind of people who can help them. They are also connected. Now, what happened was, with the first 2 days of their launch, they were able to, or the Person Finder was updated 5,300 times, because it means that so many people are using it. They wanted to know their neighbor, or they wanted to know their kith and kin. That happened. So maybe I will take this. Okay, yeah. Okay, instead of going for this, I will take it live. If already any of you know about it, it is maybe you can share also in that case. Otherwise, able to see that. So when I click on to this Person Finder, I'm directed to this page. Now in this page, maybe I wanted to check whether the person who is whom I am searching from him, I wanted to get some information whether he is able to answer or whether he is in a position to respond. I can just search here. Okay, so for example, if I search your name as Kotai. Okay, so no such person. Maybe I have mistakenly search for this person. when I search, it is saying no such person is available. Now, what is happening is who are all participating in that Google person finder page, their data is available. Now I'm searching for this person, she is not available. So I will just create a record. Now it gives two options. Either I want to give about my presence, or I wanted to be a member of this. I can choose that I want to input my own information, or I want to input someone else's information. Now I'm using someone else. I wanted to see someone else. I'm searching for someone else. So their name also I can enter. So the name was not there. Okay. So and now I'm just saying that this is the new record. Okay. So now when I just like that, the data is not loaded. Instead, they are trying to find out who is actually searching for this particular person. So maybe giving this. Okay. And if you want to give source of record, you can give that. Okay. So this is how, if you want to give your own address, suppose you wanted to, they will get connected, you can. And there are some expiry, like how long you wanted to be in that. With all that privacy concern, you can save the record. Okay. So now I have created a record for Kodai. In the sense, I am searching for that person. So now if someone else is joining into the group, they will, if they know that, they will be okay. Now, what is the next thing? Now, this person, I was searching for Kodai, and she was not there. And I wanted to say someone that about Kodai I know. Okay, so and if they are getting in, they will see that actually Kodai is somewhere, and about Kodai, this person knows about it. And this also can be given with certain time limits. Not necessarily that once you become a member, you need to be there forever, one thing. Or if I wanted to delete the record also, I can delete. Okay, this is how it goes. Maybe I am taking much time. Okay. So I will go back to the so this is what I told. This is how the thing works. Okay. Then next one is adding details of the creator. This I did. Okay. Now, this part is about Facebook. This you must have always seen when you are using your Facebook. In case of crisis time, if you wanted to convey that you are belonging to that region. So based on your location, it will tell you what are the next things available. In the sense, it will say in that location, what are the recent crisis, and there also you can update. Now, when you are messaging that, if someone from that side or from someone else, if they are looking for you, they know what you have done under crisis condition, what is the message you wanted to display to them. That kind of information you will be getting. Okay, yeah. Coming to the almost fag end of my talk. So this social media mining is very recent research topic, because all of us are connected, well connected through digital data only through social media. Let it be a Facebook, Twitter, or any other social media, if you are even Telegram, whatever it is. Now, all this, every place, the data can be used for disaster management. So social media is what? Now the social media, we are really sharing really a large amount of data. Now in all aspects of disaster management, whether it is a mitigation or preparedness or response or recovery, whatever may be the phase, definitely the data which you are having, you can be effectively used. For example, you wanted to, in mitigation also, you have certain subtopic, right? Hazard monitoring, sonitation, and geosensor approach, whatever you wanted to. Now, this, every place, the data can be used. Now, as a disaster response team or a disaster management team, I should know which kind of data will help me in taking the decision, whether it is a prediction or you wanted to really analyze what is happening around. For everything, you need to know, as a disaster management expert, we should know which kind of data you should collect. For example, you wanted to find a person, someone is messaging saying that through some social media he is in danger, right? So if he is in a particular location, so naturally is with the location, if I am able to track, it is fine. But nowadays, because of this privacy, now we are stopping or we are not allowing allowing anyone to know my place for a privacy reason or security reason, whatever it is. So at that time also, they will be in trouble. Now, for these kind of things, researches are going on. Even though I don't declare exactly in what place I am, at least if I'm able to find out in which region it is happening, that is one way of getting the right data. Because of privacy, we may be losing information. That if everyone started, because of privacy, they don't want to give any data, we cannot analyze. But at the same time, if we are telling the public that your data is safe, your privacy is maintained, but still I'm not bothered, or no one is bothered, like who is affected with what disease. But we definitely wanted to know how many people in that region is affected with particular disease. Maybe it is, or particular place they are affected with this kind of damage. Now, these informations ought to be collected, and this can be done only when you make the people believe that their data is not used or their data is not misused. Now, for that, there are a lot of research going on how the privacy is to be maintained while information is also collected. Now, this, and similarly, the data, whatever you are collecting, whatever may be the type of the data, it is the way in which you are going to analyze, you will be getting the better solutions. So the last one, this was already told by Madam, ARIMA model will be better for prediction. This was the case in 1970. Almost 59% of the global global death toll value was 59%. So now rising global temperature, climatic change, floods, cyclones, all these ought to be predicted to avoid these kind of major disasters. And the last one about the Ukraine war. Why I wanted to tell this here is data and services have become vital links in the conflict for Russia and Ukraine war. And now they are very much afraid. Till now, I was talking about how effectively the data can be used for the betterment of society, for solving the issues, for stopping the disaster or recovering quickly. All that the data is used. But see the scenario now, because this Russia-Ukraine war, Google has disabled live traffic data from being displayed in its Maps app in Ukraine. That Map app, normally the app displays the information by collecting anonymous data from the Android smartphone. We don't know who is actually, through the smartphone, it can collect. So which shows how busy roads and different places are, but it has now been switched off in the region temporarily to protect users. See the power of data. The power is so high that now you can utilize it in the positive positive side rather than this way, because now people are afraid of it. So Twitter is also has suspended this, and the Telegram, it is there, but this words of founder of Telegram, they were telling Telegram channels were increasingly becoming the source of unverified information, and he did not, and this person did not want the app to be used as a tool that may deepen conflicts. So we have to be very careful. Big data is really big, which will help us, it has to be handled effectively so that right things are happening at the for the betterment of the society. Yeah, with that I conclude. And if you have any anything to be discussed, I'm here.
Thank you, ma'am. Thank you so much, ma'am, for your thoughtful insights, and you have thrown a wide light perspective on big data as well as the real-time live example with the person finder also, ma'am. It was a great experience, ma'am. Let me open up for questions. If any questions, participants, you can float it in the chat box. What is data management system in disaster management? Ma'am, you are in mute mode, ma'am. Ma'am, you are in mute.
Yeah. Sorry. So it is not that no specific data management system for disaster management. At any database, if you are able to manage the data, if it is the only thing in the disaster management, you may be getting numerous variety of data. When you have database management, in simple terms, data management, normally we talk about database in which has structured data, very structured data. Whereas when you go for disaster management, that is not going to help us. The data from different, that's what we told, it is not that data management, it is the big data which plays a role in disaster management. We need to connect different data, whether it is numeric data, textual data, that GPS data, satellite data, sorry, even the photos, everything is to be connected so that we can take best decisions. Okay, there is no, in the sense, if I know to handle the data, and if I know the management system for handling the data is one part, definitely it is needed. But directly, I cannot say that data management system in disaster management. It is that the way in which you are going to handle the data, the type of data is going to decide your data management system is best suited for disaster management. Maybe am I answered correctly? I don't know.
Next question is, yeah. Next question: how data can help scientists and countries to prepare and cope up with the natural disasters?
Yes, this was told by the previous speaker also. Definitely.
This was answering for past 2 days, ma'am.
Naturally, it is. We are also eager to know that. As we were, when the COVID situation arises, they were telling 100 years, every 100 years it happens. Correct. So this 100 years data, we would not have realized. Maybe 200 to 300 years back, the data was collected, and based on that, they were telling it happened. So the amount of data which you wanted to analyze, as she was telling, the cycle, it may be per year, it may repeat. Maybe it be easy for us to detect, or we can predict. Maybe we have a data set for 100 years, and assuming that what all happens during that 100 years, definitely we can predict. We can choose a model which can predict accurately. But the cases like COVID, they were telling it every 100 years once it happened. So in that case, if we have that kind of data, definitely we can predict natural disaster. But of course, nature has more powerful 3-wise data. Do you think we can daily COVID-19 test results as a big data for? What is that, sir? The question? Someone else?
Based on the 3-wise data, can you please type the question again so that it will be useful, more clear? The other question is, ma'am, how big data plays a vital role in man-made disasters?
Man-made disasters. Yes,
like,
this is what.
Since you are discussing about Ukraine war and conflicts, so they were asking this question.
Yeah, Yeah, the thing is, as I told, I put a disclaimer that all the predictions, all the things can be done only when we are very sure that we got the right data, correct data, true data. If we are collecting data, if it is right, and as you said, man-made disasters, if we have the data, definitely the data, as long as the data is clear and clear means true data, definitely we can predict. But really it is a question mark whether we collect all the related data. It is a question mark. Maybe it is very difficult to answer.
Added that is, can we consider daily COVID-19 result as a big data?
See, daily it is okay. This is what he asked: how 3V is connected to COVID data, isn't it? Now, normally, maybe I forgot telling you the definition of data. Big data. When I told there is no proper, only this much GB is called as big data. We cannot declare like that, because when you don't have existing technique to handle that data, that becomes big data. Okay, so if you have a system which can store, it can work on 100 GB data, but you have only 50 GB data, but the type of the data which you are going to handle is cannot be handled by the tool which I am having, then it will be classified as big data. When you say COVID-19 data set, daily they are giving the data. It need not be a big data, but already I have predicted, a model was already developed, and if you are able to improve the learning method, like earlier it was the previous day it happened like that, and day before yesterday it happened. So all these data are stored, and today's data, it should be incremental. The today's data, whatever it happened, it should learn from the new data. So that process we are improving on the algorithms. It in the sense reinforced learning. Whenever your new things comes in, it will be giving bonus marks for that, and that learning happens. So there is no reason that only disaster management can be done with big data alone. But at the same time, as long as you are able to handle variety of data, voluminous data, and with the speed with which you are collecting the data, it is existing technology may not be able to handle. In that case, we say that this is big data. And when the volume is high, definitely we will be able to get better predictions. That's what I will say. Accuracy will be definitely better. It is something like when you have all the time, the experienced person, when they take the decisions, it is the right decision. Mostly it will be right. Okay, same way only the experience. But at the same time, the experience is in one domain, and if he is asked to take decision in another domain, naturally we cannot expect the right decision. Same way here, if the data is from the data is relevant data, if you are analyzing, you will be getting the best results.
Thank you, ma'am. Thank you for your kind explanation, ma'am. It was very much interesting as well as very much useful. It shows that your 30 years of experience is showing here with your great content, ma'am. Thank you very much, ma'am. Thank you.
Thank you. Thank you for the opportunity. Thank you for patient listening also. Thank you, participants.
Thank you.
Thank you.
Thank you. So, dear participants, the feedback link has been posted in the chat box. You can find out the feedback link and you can fill the feedback. The last speaker of this 3 days training program, I would like to introduce Dr. Alex Joseph, an associate professor at School of Public Health, SRM Institute of Science and Technology. Sir is a seasoned epidemiologist. Sir has secured a prestigious BMJ award for his research and development. So a man with good number of projects and publications, and he is a much spoken figure in Center for Ministry of Health and Family Welfare Department, as well as in state, as well as in central government, especially at ICMR. So Sir is going to discuss about the epidemiological surveillance relevant to disaster management. Sir, the stage is for you. Over to you, sir.
Yeah, thank you, Dr. Vignesh. Is my PowerPoint visible?
Perfect, sir.
Thank you. First of all, I would like to congratulate the organizers, Dr. Vignesh and Dr. Sushma, for arranging such a wonderful series of talks. So day by day, each this particular session is very interesting and very relevant. So I'm also so grateful for inviting me as a resource person here. And this is a very great learning opportunity for the students as well as for faculty like us. And congratulate Dr. Vignesh for conducting such a informative talk. And now I am given a few minutes because I think we are coming to the fag end of this particular session. So I will start with a quick roundup of the use of technology in disaster management with a special focus on public health disasters. So being an epidemiologist, I will be focusing basically on the epidemiological surveillance using technologies. So we know that like for any disasters which we were discussing in the previous sessions, the information communication technologies plays a very significant role in prevention, mitigation, response, and recovery. So in the all phases of disaster, irrespective of being a public health disaster or a other disaster, the information communication technologies play a major role. So it helps in timely prediction and effective communication. Then it also helps the government agencies and the humanitarian actors to respond to disasters. It also helps in decision-making process, making it easy for even the rescue operations. So we know that the principles of disaster management, we can put it into 4. That is the multi-hazard. That means there are multiple hazards. Multi-technology, that means use of multiple technology. Multi-phase, that means a different phase, and multi-stakeholder. That means we will be using technology like for any other disaster management in all these 4 phases. So multi-hazard, you know that there are natural and man-made earthquakes, cyclones, the epidemics that we will be talking today. And multi-technology, that means the use of satellite, radio, mobile networks, internet, and much more. Then multi-phase, that means at each stage of this particular disaster, in the mitigation phase, the preparedness phase, the response and relief, and recovery and rehabilitation. So today we will be discussing this with respect to a public health emergency or a public health disaster. And you know the name of the public health disaster which we are currently undergoing, that is a COVID-19 pandemic. So multi-stakeholders are involved in that. We have government and humanitarian agencies, international organizations, civil societies and community, private sector. So there are multiple people starting from the grassroots level, that is the local community, to the highest organization, that is the national and international agencies. And going in depth of my topic, so we are all aware that public health surveillance, it's a continuous process. A survey and surveillance, the difference is a continuous process. It is systematic process, and it also needs analysis and interpretation. For what? Planning, implementation, and evaluation. Okay, so now you understood that having a public health surveillance in an emergency or a disaster, it should be continuous, it should be systematic, it need to be analyzed and interpreted and disseminated. You know that this is humanly impossible to do the continuous monitoring, the systematic collection, analysis and interpretation in a limited time. You have seen that small outbreaks, we were struggling. When a pandemic like this struck us, we really understood that the classical or the traditional way of surveillance was not advocate. So new technology or the use of technology was leveraged for this particular process of public health surveillance. So today we will see a few of those communication and information technology tools which was useful and in what way it was useful. So you know this traditional, right? It's a traditional way of giving some helpline numbers. We know that nobody even remember the helpline numbers, and I'm sure number yaad hai kya? That is the quotation they are given itself. How many of you remember this number 1075? Can you raise your hands? Is there any hands raising here?
3, 4, 5, sir. 4.
Yeah,
5.
it's hardly we
10,
can remember. We can hardly remember the number 1075. But the next thing, this particular name has become a household name, right? Each and every member in the household know. Are you on Twitter, Facebook? No, that was not the question. Are you on Arogya Setu app? That was the question, right? During the pandemic, the question was, are you on? It was not, are you on Tinder? Are you on Facebook? Are you on Instagram? It was that, are you on Arogya Setu app? Okay, so that was the impact. With this number, traditional 1075, none of us are able to recollect it, or what was the relevance, or I am hardly, I don't think even anybody has made a call to this number, but all of you are having at least downloaded once Arogya Setu app in your mobile phones. So that is the impact of a new technology being used and being popularly used. It's not being rolled out, but being used actively. So we can see that it is not only India which came up with the possibility of having an app or a surveillance system based on an automated technology driven, which can be accessed by all. There are many countries, more than 25 countries around the world came up with technological solutions for contact tracing. Basically, that is the word we use for in an epidemic to find out the people who are infected, or find out the people who might be at the risk of getting infected. That is called the contact tracing. And these apps are called as contact tracing app. But from the traditional contact tracing apps, these apps have developed, evolved, and raised to the need of the time. That means they are no more just a contact tracing app which needs to be used by the health professional, but it became a larger public health tool. So you can see that there are many countries to name a few. Australia came with COVID Safe, Japan, then UK. There were many countries, and few of the names I have mentioned here. Stay Safe by Philippines, MyTrace by Malaysia. And you know that in April 2020 there was a announcement that all of you should download the Arogya Setu app. And I know that most of you, and including me, we were hesitant to download it, because we were thinking, why we want to download something the government is saying all of a sudden, how it will help me, because we were new to this, we were not aware. So let's see how it was. We knew it very limited, that it helps to limit the spread of COVID-19. That was the general information, and none of us were aware how. So it also said that you use Bluetooth for contact tracing, and contact tracing itself is a very technical terms, and nobody knew that. And it helped in mapping of the likely hotspots, and also to help dissemination of relevant information for COVID-19. So this Arogya Setu app, which was developed in India, an indigenously developed app, had multiple objectives. And one of the most important was also to dissemination of relevant information when a lot of misinformation was floating around. So now you can see that more than 21 crore users are active users are there for the Arogya Setu app. This is considered to the largest app which has the most number of people accessing or using it, available in 12 languages and across the platform, Android, iOS, and Linux platforms. So this particular Arogya Setu mobile app has been brought in under the special powers of the Disaster Management Act of 2005. So how it was used, now I don't need to explain this. It was completely free to download and use. It was available in Google Store and Apple stores, and it was supporting almost all the major languages. That means almost 11 languages in India was supported by this particular app. So how does that app work? We know that we need to enable two things for the app to work efficiently. That is the GPS. That is, you need to switch on the GPS connection and also the Bluetooth connection. So that was something which people were also reluctant, because their information about their whereabouts, that where they are moving around, and also the Bluetooth. So some privacy concerns, these were all there. So user need to give permission for the Bluetooth and GPS, and the Bluetooth functionality and the GPS accuracy are the two most important things which affect the functionality of this particular app. That was considered to be one of the challenge also. So how was the app working? So we know that there was the geographical location was tagged almost for every minutes, and it was stored with a user precision, and the record was not sent to any other platform, but it was temporarily stored in the phone. So there was also an area where you can do a self-assessment. That means there will be a set of questions you need to be answering, where they will say whether you are likely to be exposed for any COVID-19 like infections. So you guys might be remembering there was your status, then self-assessment, then COVID updates, and e-pass. That was something which was shown as coming soon when when this particular app was made. So the structure of the app, there was 3 sessions mainly. One is the your status, then self-assessment, and COVID-19 update. So your status actually looked as it collected some basic information. That is the basic surveillance. You need some basic information like the socio-demographic variables. So it collected your location, your age, and the number of people who you come in contact. When the GPS is on and the Bluetooth is on, it will communicate with another device which is having the same app, and that's how the data is exchanged. That's how it detects that you are in contact or you are in contact with another person who is using this app. So the whole success of this app was based on the number of users and people who are enabled the Bluetooth and as well as the GPS. So this was that was the need. There should be universal coverage for this app to make it function effectively. So it used the age, and people like elderly people were even given a more priority because of their highly likely chance of contracting the virus. And similarly, people who are in the hotspot with the location of the GPS, they would understand where the government of India notified places where hotspots are there. They were also given alerts regarding that, saying that you are entered as hotspot area, or you are leaving a hotspot area, or you have visited a hotspot area. The second module in that was a self-assessment. Every epidemiological surveillance or a screening test, we have some set of questions. So to make it was not a self-diagnosis, you can say it as a screening. So screening is done on apparently healthy people. So we get large number of people. So it should be easy to be used, and it should be easy to be understandable, and which can be replicated by many, even for a layman. That's how this app was decided. So there was a set of questions regarding the health condition, and the answers will determine whether you are at a high risk of contracting the virus. Okay, so they would give a final checklist that how likely is that your self-health status is being assessed. So that was the self-health assessment. You know that when more than a crore people are affected or they are at risk of contracting a disease, you cannot be going to a doctor or a health provider to get your a disease or your risk assessed. So self-assessment, and this technology was helping them to understand or do self-assessment better. Then regarding COVID-19 update, there was a lot of infodemics. There was a lot of false information. There was a lot of good information. People did not know what is the reliable source. And it was also the plan of the government to include the both locally and nationally relevant information and updates to the citizens at their fingertips. And that helped preventing of rumors and misinformation. So what was the need for a person to download the app? The app assessed whether you and me, we are residing in a hotspot area where there is a high chance of occurring of the virus, or the spread of virus is high, because it is not static, it is dynamic. It keeps changing from days and months and places, and we cannot be always coming up with a list of places. But this app will automatically show that when you are reaching a hotspot area or not. Then it also gave the safety guidelines when you are approaching a hotspot areas. Then the self-assessment will say if you are asymptomatic, whether you are symptomatic of COVID-19. So it also gave quarantine guidelines. It also was used for contact tracing. That means it was notifying that you come across a person who was having COVID-19 or who tested positive after a few days of you being in contact with that person. So that app was tracking it and giving information feedback after even few days of you being in contact with the person. And also it was giving also the active number, the number of people who are affected in your locality as well as in the country as a whole. So there was an integration. I told that it started all as an app for just contact tracing, but the information or the app was used for multiple other things regarding fighting misinformation. And now we have it is integration for other facilities like e-pass facilities. So e-pass facility was also made available so that people can move around freely without going physically getting an appointment. Now coming to another technology apart from the Arogya Setu app, which was one thing was geotagging. That means GPS-based tracking. You know that you have first apparently healthy population. Now you come, you do your contact tracing and find out that there are people who might be higher risk. So these higher risk people might have been people who are be contacted by a person who has already been infected with COVID-19, or maybe they had traveled from abroad, or as a part of evacuation process, they might have been in a quarantine facilities. So there was a need to track these people. And again, it was physically or manually impossible to track this many number of people in this many facilities and give them the right information at the right time. So the technology, GPS-based tracking was again used. Geo-tagging of each and every individual who lands in the country from a COVID-prone area or abroad was noted. There was a patient or a person ID, the name of the patient, gender, age, address, contact number. This led to the help in, especially in Kerala, where the first case of COVID-19 was detected in the district of Pathanamthitta, where they were able to effectively come up with the route maps of people who are in quarantine, who actually jumped quarantine, or people who are not aware that they need to be staying in quarantine, and they visited multiple places. So a route map was made very easy with the geotagging, so that they could say that these are the areas where this particular patient or the particular suspected patient was traveling. So that helped them to do the contact tracing, and this was one of the first to be implemented in the country. Then coming to geo-fencing. So we have heard about fencing, like people guarding you, right? Or this is your fence, you should not cross your fence. But you can guard, or policing can be done to make sure that people are not crossing certain places where they are supposed to be in quarantine facilities, right? But it one number, 2, 3, that is possible. But if the numbers are in thousands and lakhs, it's highly impossible that you can do physical policing. That will lead to a lot of law and order issues rather than caused by the pandemic, and it will also cause panic. So the Kerala police was again the first to come in the country to come with a geofencing. That means they would mark an area with the geographical location systems, saying that this is a particular quarantine facility. If a particular person who will be again geotagged is crossing that particular area, the notification would be given. Okay. So this was in lieu with the Department of Telecommunications. So there was a standard operating procedure which they later came up, and it was called as a COVID-19 quarantine alert system. So this will collect the phone data, the patient's device location on a secured platform, and alert the local agencies in case of a violation. You know that in the case of an emergency, you cannot be calling multiple people. It's an automated system. This the quarantine alert system was giving alerts to the concerned people. That means the nearest COVID centers, where they were screening the people and where they were aware that this many people are put in this particular quarantine facility. So this helped in decentralization of the process and a quick response for the people. So there were designated officials. When the location of a quarantined person changed, the information was passed from this particular software to those designated people. So we all had the doubts of the privacy, and this itself was a matter of discussion in the country. So they made some of the made checks so that there are no misuse, because many relevant people, including politicians and celebrities, were also under quarantine. So Indian Telegraph Act 1885, some of the provisions in that were added so that you need to get the permission from the Home Secretaries so that the geofencing or the information by the SMS or email can be made available. That means the Department of Telecommunication will provide on the request or the permission granted by the Home Secretary. And regarding the safety, it was found that there was a practice they followed was that the system will delete the information, that means a phone number or the geographical information system, and the entire data will be deleted after 4 weeks. So there were standard operating protocols to safeguard the privacy of the people. So coming to the other areas where the information communication tools were used for this COVID-19 scenario or as a public health emergency was in telemedicine service. There were apps like Sanjeevani app or called the doctor app, or there were even other telemedicine where there is no need of an internet connection itself to satellite communication and with the available broadband connection. So the technology was used for even clinical management where doctors were not seeing the people directly, even for a regular or non-communicable disease like chronic diseases. So that the other services are not halted, the same clinical management, telemedicine was also used that we have seen. Apart from the Arogya Setu app, some of the other disease surveillance tools, that was the Project Eagle Eye, that is again from Kerala, where they use the drones. The drones were used to monitor the people and how the movement of the people, and especially when lockdown or triple lockdown, like strict method was there, police could not be reaching each and every place, and secluded places they were using the drones to do this surveillance. And Corona War Room, that was something which you have seen or you have heard, the war room kind of thing when there is an emergency. So the Corona War Room had a lot of digital displays, and Madam has told about the big data. That kind of data was analyzed randomly, systematically, and being displayed to the stakeholders, so that at the center as well as the in the grassroots level, those information could be easily disseminated. Then collaboration like Corona Safe Networks. There was open source platforms like Google, which were providing the right information, verified information. Then services. When you look at the services, you can see that when the first phases of disaster was over or the pandemic was over, and slowly we had a vaccine, we need to have an effective ways to roll out the vaccine. So again, the use of technology, COVID was the platform which was used. Of course, there were glitches in the platform, but that was used to even download a vaccine certificate that is contactless. So it added to the purpose as well as a convenience. That means no touch, so no way of spreading the disease through physical touch or close contact. At the same time, convenience also was being catered by such a software where the certificate was automatically downloaded. So you can see that even vaccines, India was one of the first countries which, with the help of the military, they were able to use the drones to deliver vaccines. A place where they were supposed to be covering by 3 to 4 hours was covered in just 15 minutes. That's a hilly terrain in northeast areas. So such initiatives were also made possible because of the highly sophisticated technologies, and also using the existing technology for a repurposing for a COVID-19 purpose. So of course, something which we all know, social media, that was one of the benefit as well as also a threat. So social media was also playing a larger role in disseminating credible information such as WHO, Government of India website, Arogya Setu app, all those came from verified profiles. We came to know that who are the verified people who can talk about that. So Google, Twitter, all were giving verified badges for those kind of individuals or people or the sources where you get credible information. So issues, you can see that there were privacy breaches. Of course, there were many privacy breaches, and later only the governments were accused for the breaches, and later only they came up with acts, and not acts, they were come with standard operating procedures where they could minimize those security breaches. So previously, police use, that was one of the use the call records of people who are tested positive. That was again considered unnecessary, and but during an epidemic, under the Epidemic Act, the citizens are limited capacity to raise their voice, but still those were considered and rectified. So Another problem with the use of technologies in a disaster, especially in a public health emergency, is second thing. When you compare with privacy, the second most largest thing is equity, because we were much aware that there were the penetration of smartphones, internet, high-speed data was very limited, especially in rural and suburban places. But in urban places, it was well contained. So there is, of course, a gap, but those gap were almost in 100 crore people, you can say that almost 20 crore people downloaded. So that is the gap you can see, or that is the inequity you can see. So that is, of course, something which you need to be keeping in mind while rolling out this kind of programs. And that was also a learning for all of us. But you can see that when it came with the COVID application, so that was not considered as a hindrance. People were even mentioning why such an vaccination drive was put into a digital platform. But we knew that there was other mechanisms, or the collective of people and communities which came together, so that even the elderly or even the illiterate, even the rural people were able to register in COVID platform. So that was also one of the learning which we understood how to overcome such a challenge. So this is not only something which is related to India, but also from all over the globally, all over the world itself. But India has shown us that having the largest population and having the highest coverage of COVID-19 in terms of number, we were able to again prove that this is possible by leveraging the technologies. So some of the topics which we have already seen, I just want to bring it again to the context of COVID-19. This big data, that means for particular the Arogya Setu app, the mobile number itself, this number 20 crore is not a small numbers, right? So 20 crore numbers, we're tracking them real time. That was a big data, again, application of big data. Artificial intelligence, that was, there were chatbots and robots which was used for response for your automated questions. There were WhatsApp chatbots which gave you information when you asked a question. Okay, especially the emergency hotlines, and now also when you ring a phone, you can hear the mandates of COVID-19 to take vaccination. So all these are based on artificial intelligence, and that has been well applied in this pandemic as well as in a public health, and can be used in any other public health emergencies like this. And Internet of Things, you know that Internet of Things based on sensors, it gives it actually analysis based on a cloud computing. So when those a person who come in contact with another person, those information is shared with the cloud, and it is giving feedback to the people. So again, Internet of Things was also something which you heard it, and you felt that it cannot be used that massively in a public health outbreak. That was also used. Robotics, of course, as there was we have seen robotics and people used in disaster in rescuing and all, but we have also seen that in sophisticated laboratories as well as hospitals, robots were used to take care of or supply the medicines and other things for the health workers. So without putting a risk of the health workers to the exposure of COVID-19, robotics were also used. And blockchain, that means blockchain is one of the area which you have heard it very frequently, especially in the cryptocurrencies. But that could be also, that was not used in very thing, but it can be also used to ensure that there is a transparency. That means you were standing in queue for remdesivir medicines. So the tracking of the vaccine, these can be all integrated with blockchain. So that is also another possibility. And we had other platforms which were using blockchain, which we were not aware because we were not the end users, but it was used by the government of India. So to note that we need to understand, or we keep in mind that our end goal of a disaster response or a public health disaster response is not to include or technological solution. It is never an end goal of a disaster management response. But we understood that it was one of the most essential and crucial element, and that was a need when the scale or number was something so humongous that which could not be made possible by human. So you should always keep in mind that it's not the end goal, but it was used as a tool. So, and also we can know that the inequity exists, and it is not always the most fancy or IoT or the blockchain or Internet of Things, or it is not the big data, but also very less fancy things. That is the COVID helpline itself. That itself served many number of people, right? So we should keep in mind it is not only the fanciest or the most sophisticated technology you can use, but the traditionally tried, tested, proven simple SMS where you don't need internet connection at all. You need power so that you get some information, authentic info. So that should be always leveraged. And we need to be also keeping in aware that it is the most vulnerable. That means who are affected may not be only the people who is using this technology, but there will be people who are under the command and control of the disaster response. So this kind of controlled or organized effort can be only possible, or the timely response can be only possible when we use technology. So when we think about only the end user, that is the most vulnerable people who are affected by the disaster or the public health disaster, you should also see the other end where people who in command and control who will be using this more effectively. And of course, this use and effective use of this technology can be only possible by the cooperation of the responders, the users, and the providers from the very stage of development. And it is the topmost priority we should be keeping in mind. So with this simple words, I like to conclude my presentation. I hope I was able to generate your interest back in this use of technologies, especially in a public health emergency. Most of the things are aware, you guys were aware of it, but I was trying to put this all together and make this presentation. And thank you, Dr. Vignesh, for giving this wonderful opportunity. Thank you for challenging us to come up with interesting topics and presenting it in the way it is easily accessible to multiple stakeholders, multiple students, multiple audience. Thank you so much.
Thank you very much, sir. Even when during that COVID time, when we were with the Arogya Setu app, under compulsion, we have downloaded that Arogya Setu app and we are in mobile. And still it is in mobile. I haven't opened it yet. And you have throw a very good light on that, sir. And it is very much useful. So thank you for your great lecture on this epidemiological surveillance, sir. It was very much interesting and very good comments are floating on the chat box as well, sir.
Thank you.
So, dear participants, from your side, if any questions, yesterday some questions were related to Arogya Setu app, sir. So I was, I told them that today the expert will be here. So he is here. You can ask any questions if required.
I think they are all saying thank you because it is a fag and they need to leave.
And most of us received their feedback form, so they may think that it would be done. The training is almost done. So thank you, sir. Over to you, Aradhana.
Sir, am I audible?
Yeah, perfect. Please switch on your video. Sushma ma'am is there?
No. Sir, Dr. Sushma is in a meeting and
yeah, no problem.
Okay, sir. So we have successfully completed the 3 days online training program on technologies in disaster. This online training program was a joint initiation of National Institute of Disaster Management under Ministry of Home Affairs, Government of India, and SRM Institute, Tamil Nadu. So today for this session, we had with us Dr. Jennifer. Dr. Jennifer explained the disaster management cycle, which included mitigation, preparedness, response, and recovery. Ma'am also highlighted topics related with role of statistics, data and its type, choices of statistics, mostly qualitative and quantitative, regression analysis, time series analysis, overcrowding in an emergency depth. The second speaker of the session was Dr. Puvalam. Ma'am shared importance of big data in disaster recovery management. Ma'am also discussed about volume, velocity, variety, history and innovations, role of data in disaster management, crisis mapping, bringing people together, preparing for emergencies, and social media mining. Lastly, Dr. Alex Joseph explained thoroughly, in detail and in depth regarding the role of technologies in disaster management with focus on epidemiological surveillance, information and communication technologies for public health disasters. Sir also highlighted the key role of multi-stakeholders, importance of geotagging and geofencing, and emphasized on engineering technology trends that can transform disaster management. So, this was the recap of the final day training session. Now, I request Dr. Vignesh to kindly address the vote of thanks and the closing remarks for the training program. Sir, over to you.
Yeah, thank you, Aradhana. Being a convener of this 3 days training program on technologies in disaster management with the collaboration of SRM IST and the National Institute of Disaster Management, I express my sincere, heartfelt thanks to Taj Hassan sir for his. Without him, the event does not throw the light. And I also extend my heartfelt thanks to our Dean, Professor Padma Venkat, who has given her valuable guidance and support in this regard for this successful 3 days training program. I also extend my heartfelt thanks to respected chief guest, Professor PG Divakar from Indian Space Research Organization, and Dr. I. Ananda Kumar, who is a district revenue officer, who has delivered their chief guest address and has initiated the event successfully. And I also extend my heartfelt gratitude and thanks, sincere thanks to all the speakers who have spent their time in a short notice, and they have come up with a very good presentations and interesting presentations, which was very much reflected in the chat box and as well as the question and answer sessions. So it was very much interesting, and many feedbacks. We have already received almost 170 feedbacks from the participants, and we could see that most of the feedbacks are very much positive. So it was only because of all the speakers which they have showed up with a good time, and they have spent a lot of time on preparing the PPTs in their being their busy schedule. So it's my heartfelt thanks to all the delegates and speakers who have given their participable time, which is very much useful for the participants. I also extend my heartfelt thank to my charismatic mentor and guide and my collaborative research partner, Dr. Sushma Guleria, from the National Institute of Disaster Management, who is a bridge between the National Institute of Disaster Management and School of Public Health. So, Madam, without you, this approval and other administrative process would not be easy. So, thank you for your kind support and guidance from the Ministry Department. Thank you. And also, I would like to extend my heartfelt thanks to young professional Aradhana, who was enthusiastically handling the sessions with all rapport report and as well as the closing remarks and other moderating sessions, which is very much handled by Aradhana. Thank you, Aradhana, for your kind support and delivering the right way of moderating the sessions. And I also extend my heartfelt thanks to all the participants from different countries. So I could register that almost we received 1,100 registration till date. We have received almost, we have closed the registration on Monday. So we received almost 1,100 registration for this 3 days training program. In that 1,100 registration, when we see for past 2 days attendance record, we have seen that almost 600 participants have participated actively, and they have floated various questions as well. So it was a great opportunity for the students and for the participants globally. And we can see that most of the participants are from Sri Lanka, Australia, USA, Singapore, and it is very much recordable that many international participants also show their interest in this regard. So thank you one and all for your kind participation and active listening. On behalf of SRM School of Public Health and on behalf of all the faculty, I would like to extend my heartfelt thanks to National Institute of Disaster Management and the team. Thank you one and all. So the feedback form is pasted in the chat box. You can have a feedback form. Once the feedback form is submitted, we will check your attendance with our database, and then we will issue the certificate. Maximum by this Friday, you will receive the successful participation of certificate if you get satisfied with the 80% of attendance. So thank you one and all. Thank you. Looking forward to the further training programs. Thank you. I would like to request all the delegates, panel members to switch on their video so that we can take a pic of. Aradhana? Yes. So thank you, one and all. Thank you, Puniamal, madam. Thank you, Alex, sir.
Thank you, sir.